so this is going to be a review for your exam that you're going to take tomorrow, Thursday, and we're going to go through each question, make sure that whatever we go over, if you have a question, just raise your hand and I'll answer it. This is going to be a live recording during second period. And for those of you in first period watching the video, I deleted your recording because I forgot to turn the mute off of my microphone. So for number one, it says if a net force equals 0, what will happen? A, the object will change its speed. B, the object will change its direction. C, the object will change its speed or direction. Or D, none of the above. So what do you guys feel is the best answer for number one? Yeah, the best answer here is D. And the reason for that is because if the net force is 0, remember force is a vector quantity, so it has a direction and a magnitude. And in this case, for it to be a net force of 0 means that you're not changing your direction. Otherwise, you'd have an acceleration, you would have a force. So there's no change in direction. And then the other thing you know for sure is that the speed is constant, which means it's either stopped or you're going the same speed the whole time. Like if you're going 50 miles per hour on cruise control in your car, then that means even though you're moving, you still have a net force of 0 because the engine's pushing you forward to get you up to that speed, but then the air resistance is slowing you down enough to where they're canceling each other out and you just stay at that speed. If you want to get faster, what do you have to do? You have to take yourself off cruise control and add more force to get a faster acceleration, right? So in this case, the best choice would be D, none of the above, because we're not changing our direction and we're not going to change our speed to get net force of 0. On number 2, it says if acceleration equals 0, which of the following is true? Very similar type of question, it's just worded a little bit differently. If you have an acceleration of 0, that means you have a net force of 0. Because you're not accelerating, you're not changing your force. So the net force equals 0 is the right choice here. We also know that when you have a net force of 0, the object is in equilibrium. So A and B are really saying the same thing. They're saying that the object has forces that are canceling each other out. Remember when we did Kahoot and y'all were doing the right minus left, top minus bottom, and if they all canceled out, it was equilibrium, that's net force equals 0. And then letter C, the object will not change its speed or direction. We just talked about that. If the object does not change its speed or direction, then that means you're going to have 0 acceleration, which means D here is the best choice. All of the above again. Number 3, if I apply a force to the right, then the object A must increase its speed to the right, B must slow its speed to the right, C must decrease its speed to the left, or D, slow down if going left, or speed up if going right. What do you guys think? D is the best choice. And if we look at the reasoning behind that, if you look at the choices here, A initially might be one that initially people would pick, because if you think about it, if you apply a force to something going to the right, you should expect it to accelerate in that direction to the right. The issue here, though, is that we have to take into account what direction you're already traveling. What if you're going left and then something pushes on you to the right? Well, then you're just slowing down because you actually have a magnitude of speed going to the left, but then you're slowing down, right? You're not actually speeding up. If you're going left and then something's pushing against you to the right, well, then you're slowing down. So the best choice is going to be D here. But I could see how A would be a distractor there. Number 4, which of Newton's laws describes why a skater rolls away from a wall to the left when she pushes right? So there's actually 3 laws, right, for Newton. The first one is the inertia law. And that one says that an object will continue doing whatever it's doing, whatever motion it has, unless an unbalanced force acts on it. So the way we can think about this is very simple. If an object is stopped, then it's going to stay stopped, unless an unbalanced force pushes it. If it's already moving a certain speed, then it's going to continue going that exact speed unless an unbalanced force acts on it. Okay? So that's really important also that you pay attention to that. Alright, so number 4, which of Newton's laws describes why a skater rolls away from a wall to the left? Again, the first law, like I said, is going to be that inertia law. The second law is force equals mass times acceleration. And that just basically says that if you have a bigger force, then you have a bigger acceleration. It's just an equation that describes the relationship. And then the third law, the last one, says that for every action force, there's an equal and opposite reaction force. So let's talk about that. So you've all seen like maybe karate examples where people are breaking boards, right, with their hands or their fists, right? So whatever force they put on that board gets put back on their hand if they don't break the board. So an example of that, let's say that you're trying to be a karate master and you're going to go for your black belt test and they need you to break a board. So let's say you hit it really hard but you don't break it, well then you're going to hurt your fist quite a bit because whatever force you put on that board is going to get put back on your hand. Okay? It's the same principle like if you punch a wall or if you push on something. If you hit a bat, you can feel the reverberation back in your hand whenever you hit like a softball or something. So those are all examples of the third law. For every action force, there's an equal and opposite reaction force. Okay, you can do this right now. If you push your finger into your desk and you start pushing harder and harder and harder, well then you're going to feel a force back on your finger that's the same amount. You're not that strong. All right, number 4. So number 4, if we're having to pick one, which would we pick? Which of the 3 laws? The first one, second, or third? The best choice would be the third one, because in the third law we have an action force and then a reaction force, and in this case you have a person rolling away from the wall to the left. When she pushes to the right, she's pushing this way, but then the wall is pushing her back the other way, so she ends up rolling to the left. Number 5, Newton's first law says that an object will keep moving unless an outside unbalanced force acts on it. What force constantly works against an object's motion? That's really good. So a lot of people initially will say gravity, and it's not the best choice. I do understand why, though, because there are situations where your motion going upwards would be opposed by gravity going down. Examples would be like a rocket, or if you jump in the air. Those are examples where your motion is going up, but gravity is going against you. It's opposing your motion. So that is technically a correct answer, but because it's saying that it's always working against us, there is one example where it's always working against us, and that's friction. So friction exists all the time in the real world. You always have objects that are resisting your motion. Even if you're just walking, you have friction associated with your shoes as they're touching the ground. You also have friction associated with air particles that are hitting your body. You could imagine that if there was no friction on the surface that y'all are sitting on, y'all would just be sliding around your seat right now. There'd be nothing that would keep you in place. So friction is a very important aspect of how we get around it. It always opposes our motion. Number 6, friction can only blank the direction of motion. Oppose or resist the direction of motion. So I would go with oppose. That's a good one. Number 7, what force caused a 35 kilogram object to accelerate at 7.09 meters per second squared? So that's our acceleration. This is our mass. We're trying to find force. And the equation for force is mass times acceleration. So you're just going to multiply 35 and 7.09. And if one of you could get a calculator out to do our calculations for us, it would be helpful. How are you going to do that? Just type the equation and then put the answer. Yeah. Good question, though, for the Google Docs. It's okay. I mean, just modify yours. You can copy, paste it, or move it. So did somebody do this for us with their calculator? Jesse, you have a calculator out. Can you do it for us? So it's 35 times 7.09. So 248.15 newtons is our force when we multiply 35 times 7.09. And if you wanted to write it, you could just put 35 and then put x, 7.09 equals 248.15. Number 8, it says that John drops the following items through a set of photo gates. Item 3 is way off. The photo gate is very precise and accurate. So why is number 3 so off from the others? So if you look over here, our choices are A, something stopped the object for a moment as it fell. B, he threw it down instead of dropping it. Or C, he probably moved the photo gates closer together. If you look at these trials, the third one is the time here is bigger. That should show you that the speed or the acceleration was slower. So if we know that the acceleration is slower, the speed is slower as it falls, does that make sense that he would have thrown it downwards? If he threw it, it would have been faster going through, right? And then C, it says if you move them closer together. Well, if he moves the two photo gates closer together, you guys know it takes the time from one to the other. So if he moves them closer, that should make the time smaller, not bigger. So the best choice here is going to be A, that something stops the object as it's falling. Yes, you had a question? Okay. Well, what we can do for then is just move on to the next one. I'll go back and I'll help you. Okay. Because that's just like a diagnostic thing. What's that? You can just type it in. F equals M times A. You can put spaces, make room. Alright, and then number 9. It says Sergio has a mass of 75 kilograms and sits in his chair. What is the normal force of the chair? So on this one, they give you the mass of 75 kilograms, and we're trying to find the normal force. So this one actually requires you to know a little bit about forces. So if you have a force of gravity going down, you have a normal force going up. Remember I said this exists for any object that's resting on a surface, so they actually equal each other. So if we find the force of gravity, you're actually finding the normal force also, because they're opposing each other. Right now, every one of you has the force of gravity pushing you down, but then you've got the normal force pushing back up on you the same amount. And so in this example, we're just going to find the force of gravity, and the equation is at the top of that handout, or the Google Doc, and it's going to be our mass, 75 kilograms, times what? What does that little g stand for in the equation? The 9.8, right? So we're going to use 9.8 meters per second squared. You can make it negative. The negative is going to tell us the direction, right? So if we make this negative, it's going to tell us our direction. We can make it negative. So what did you get, Jesse, when you multiply 9.8 and 75? What did you get? Okay, so negative 735 newtons. The negative here tells us that the force of gravity is going down, which we know. And then the normal force is going up, so we're going to actually make the normal force what? Positive 735, right? So the normal force is going to be 735. You want to put this little square? You go up to where it says Format in Google Docs, and then you click Superscript. And then you clear formatting to get rid of it if you want to keep typing. It's important that you guys know, I know this is challenging to do this in Google Docs, especially since it's your first time, but as you get better at it, you're going to get much faster, and it's going to become much easier for you to do this stuff, okay? And a lot of times it just requires you to take something from before and apply it over and over again before you can get better. So just keep that in mind as you work on this if you get frustrated. So on number 10, it says a 5 Newton of force is going to the left. So we're going to show a little 5 Newton force here going to the left. It's opposed by a 50 Newton force to the right. And they want to know what additional force it would take to make this object go to equilibrium. Well, if you've got 50 going to the right, you do 50 minus 5. That tells us that we have a net force of 45 to the right, right? You guys remember that? If they're going opposite directions, we subtract. So in this case, what do we have to add to the left side to make it to where they're equilibrium? 45 newtons to the left, so it's going to be C. Bless you. Matthew just sneezed for those of you watching the video. Number 11, a 55 kilogram soapbox derby car. This is your mass. Rolls down a hill going from 0 meters per second to 23. So 0 is our initial speed, 23 is our final, 3.9 seconds is our time, and we need to find the net force. It says that you have to find acceleration first, because you guys know force equals mass times acceleration. We have mass, we don't have acceleration. So to do that, you're going to use this equation, Vf minus Vi divided by T. When you plug in these numbers, it'll be 23 minus 0 divided by 3.9. So the acceleration here is going to be 5.89. And then we're going to take this acceleration of 5.89 and the mass of 55 kilograms and plug them into our equation. So it's going to be 55 kilograms times 5.89 meters per second squared. So 55 times 5.89 gives us a force of 323.95 newtons. Number 12, what net force acts on a 38 kilogram object which has a force of 153 newtons to the right and friction of 32 newtons? So for our object, we've got a force that's going this direction, that's 153 to the right. And then we've got a tiny force of friction going against it. Remember, friction opposes our motion or opposes our direction, our forces that we have pushing on us. So we have 3.2 going to the left then. It wouldn't be going in the same direction because it opposes your movement. So 153 newtons minus 3.2 newtons. Remember, we subtract them because they're going in opposite directions. And that'll give us our net force for this problem, which ends up being 149.8. There is a way in Google Docs to insert images, so if you really wanted to, instead of typing everything, there's creative ways to get around typing everything. I'm not going to take that leap and give you too many more hints, but there's ways to get around it. Like right now as you go over it, you could be using something that would maybe take a picture or an image of it, and then you can crop it down and then insert it if you wanted to. If you go to insert on Google Docs, there's a thing that says insert image, and you can insert image. For those of you who are inclined to do that, you can. Number 13, you need to draw a free body diagram of a 12 kilogram object that has a 20 newton force to the right and a 4 newton force to the left. So that would just be 20 newtons going this way, 4 newtons going this way. You also have the force of gravity going down. And you guys know to find force of gravity, it's just mass times 9.8. Then the normal force going up. And the normal force we know equals the force of gravity. So what we're going to do here, first step, they want to know the force of gravity. So force of gravity is just going to be the mass, which was 12 kilograms, times 9.8. So 12 times 9.8 gives us 117.6 newtons. And we know the normal force is the same thing because the normal force opposes the force of gravity. It's the same value. So the normal force is 117.6. The net force here is just going to be, you know, the top and bottom will cancel. 117 on top minus 117 on the bottom is 0. And then we do right minus left. So we'll end up with 20 newtons of force to the right minus the 4 newtons to the left. Will give us a net force of 16 newtons. Everybody's okay so far? And then acceleration is just going to equal your force divided by your mass. So for us, that would be 60 newtons divided by our mass, which was up here, 12 kilograms. So you should get 1.3 meters per second squared. And this equation is up at the top of your Google Doc. Number 15 is very similar to number 13. It's asking you to find the acceleration, and they give you the force, and they give you the mass. Is it on here? Maybe I missed it. Claudia found a mistake. That's okay. I'll put 14 in at the end. We'll go back to 14. Alright, so 15 though is very similar to this one. It's going to be acceleration equals force over mass. So it's going to be 3.83 newtons divided by 0.34 kilograms. So that gives us 11.26 meters per second squared. Yeah, we'll come back to 14. In the above problem, what is the action-reaction pair for the frog leaping into the pond? A, the frog pushes on the ground and the ground pushes on the frog. B, the frog pushes on gravity and gravity pushes on the frog. Or C, the frog pushes on air and air pushes on the frog. Yeah, good. The best choice here is A, because it's a contact force. Whatever you push on the ground with is going to be the same force that pushes back on you. That's why you're able to, the frog's able to leap up. Whenever you want to jump off the ground, you have to push force down, right? If you want to jump up, you push down. And so that's a great example of the action-reaction pair there. 17, this is a Pythagorean theorem problem where this is your A and this is your B. And if we actually draw it out, you'll have 3,500. This is the stuff that we did last time. And then 4,500 down. So this is going to be your A, your B, and then you're trying to find C on the Pythagorean theorem here. So it'll be 3,500 squared plus 4,500 squared equals C squared. I'm not actually going to solve this one because we don't have enough time for that.
Good morning.
Almost done. Alright, so number 18, it says you have a 160 kilogram man. He runs into a 65 kilogram woman, so she's obviously has a smaller mass. And he knocks her down. So which of the following is true? In this case, A is the right answer. The man applies the force to the woman, more force to the woman than the woman applies to the man. And we know that's the case because he's actually pushing her backwards, right? Alright, number 19. It says, what is the mass of the car that is propelled to the right with an acceleration of 3.75 meters per second squared? If the force is 3,950 newtons, so that's your force, your acceleration, and we're trying to find our mass. If you look up at the top, the equation for this is force divided by acceleration. So all we're going to do is take the 3,950 and divide it by 3.75. And you get 1,053.3 kilograms. Number 20, if the net force is applied to the object, what must happen? Or if a net force is applied to an object, this is Newton's second law. If you have a force on something, it equals its mass times acceleration. So if you have a force, you also have an acceleration. So on number 20, it's important if you apply a net force, you know that there has to be an acceleration. And then going back to number 14, since we didn't have that one up there, it says, what would the acceleration be of a 60 kilogram object being pushed with a force of 40 newtons on a frictionless table? So we're assuming there's no opposing force, it's just the 40 newtons. We're trying to find acceleration. So it's going to be force divided by mass. So that's going to end up being 40 newtons divided by 60 kilograms. And 40 divided by 60 gives us 0.6 meters per second squared. Alright, so I'm going to put this video up on YouTube. It's important that you watch it, especially if you had issues. If you didn't finish the review, you'll have time to come back to it either after the test tomorrow or on Friday. And it's not due until Friday. You'll see on the thing it's not due till Friday. And I'm also going to have this video set up so you can watch it on the tablet here at school or the laptop here at school in addition to YouTube. So if you don't have a chance tonight, although you should watch it since you're being tested, then you can do it again on Friday. Okay, you can watch it, everything we went over right now in slow motion. If you need to, pause it, and you can go back and put in all the stuff you missed. Okay, so no pressure on that. Make sure you study though. The test is it's kind of a bear. It got a lot of concept problems. There's not a lot of math problems, but there's a lot of concept problems. So understanding the 3 laws, understanding some basic concepts about force.